All right, so these are the notes for solving quadratic equations by factoring. So it says to rewrite the following in intercept form to standard form, right? So we have intercept form, and all we have to do really to get from intercept form to standard is we just have to FOIL, right? So it's distributed. X times x is x squared. X times 3 is 3x. Now we're gonna do the bottom, the second term, sorry. 2 times x is 2x, and 2 times 3 is 6. And last, we're going to combine our like terms. So we see we can only combine 3x and 2x, so x squared plus 5x plus 6. That is how we go from intercept form to standard form. Now, to solve the quadratic equation, we want to know the zeros, which are the x-intercepts, the solutions of the graph. So we change standard form to intercept form. All right, so now you can see we have standard form and we want to convert it to this intercept form. And the way we do that is going to be through factoring using the x method. So we're going to take this equation right here, and we're going to place it into this x, okay? So the b is going to go at the top. So that's this one right here. You're going to divide by the factors of a. And then you're going to take a times c, and you're going to put that at the bottom. And then you have to come up with two numbers, and we're going to call these factors. And these two numbers, they need to be able to add to b, so it's like a sum. And they have to be able to multiply to AC, which is a product. Okay? So some examples that I can give you right here is, like, let's say we came up with these factors, 6 and 5, right? So they add up to the top, so 6 plus 5 is 11, and then multiply 6 times 5 is 30. So like 6 plus 5 is 11, and then 6 times 5 is 30. Notice they're both positive. So when they're both positive, all numbers are positive. All right, let's say we had 3 and negative 4, right? 3 minus 4 is negative 1. 3 times negative 4 is negative 12. So the two numbers in this case that add to negative 1 and multiply to negative 12 are positive 3 and negative 4, okay? Another one we could do is, let's say this is 4, and this is negative 32. So two numbers that add to 4 and multiply to negative 32 would be 4, negative 4, and positive 8, right? Negative 4 plus 8 is 4, and negative 4 times 8 is negative 32. And then last, we could have something like this, negative 15 and 54, right? 54. Okay. So since the top one, we're looking at what two numbers add to negative 15, but multiply to positive 54, okay? When you look at the bottom number, since it's positive, either the factors have to be both positive or both negative. In this case, since this is a negative here, I'm gonna say they're both negative. So negative 9 minus 6 is negative 15, but negative 9 times negative 6 is positive 54, okay? So numbers that add to the top and multiply to the bottom, and we'll take this a step further when we actually start factoring in these problems. All right, for the next thing, these are gonna be the steps to factoring, and then we'll talk about how to solve after we do the factoring part. So first off, you wanna make sure that each equation is in standard form. So ax squared plus bx plus c. So let's write that there. And then you're gonna factor out the greatest common factor if you can. So we're gonna call that the GCF. So if all the terms in the quadratic in this case have something in common, we wanna factor that. Then we're gonna look for special factors, right? So these are called the difference of two squares, or the difference of squares. And then we have the sum and difference of, perfect square trinomials. perfect squared slash cubed trinomials. And we'll talk about these later on. And then after we factor out those special, or we can factor these special cases, we do that first, but if not, then we go to using the X method, and then we write out the factors, including the greatest common factor, and we'll come back to step 6 in a second when we're ready to solve. And now, when we're talking about the, right here, the difference of squares, that's right here, a squared minus b squared equals a plus b, a minus b. So an example of that would be like, let me see, x squared minus 9. So first off, I want to point out, so if you look at a squared, this is a perfect square, right? X times x is x squared. And then b squared, 3 times 3 is 9. And then there has to be a minus sign. So that's called a difference of two squares, because they're perfect squares and a difference means minus. So the way the formula works is you take the square root of this and you get x. And that's why there's an a in each one. And you take the square root of 9 and you get 3. And that's why there's a b in each one. And then one's positive, one's negative. Now for the perfect square trinomials, we'll talk about that in a bit. And the cube trinomials, we'll do those actually later on. All right, so let's get to the factoring parts that we need to be able to do. Okay, so first off, we make sure it's in standard form. That's step 1, and it is ax squared plus bx plus c. Second thing we look for is, do we have a greatest common factor? So we have 3 terms here. The first 2 have an x, but the second one does not. And not all terms are divisible by some constant. So in this case, there is no GCF. We look to see if it's one of those difference of two squares, a perfect square trinomial, because that's currently what we're looking for right now. So for this first one here, we can see that it's not a difference of two squares because there's 3 terms, and there are no perfect square trinomials. So we're going to go to the X method. So make sure you can identify what A, B, and C are. So in this case, A is 1, B is 8, and C is 15. So I set up the X, and right here we can see that B goes to the top, which is 8. We divide by A, which is 1, and then we multiply A times C, and we get 15. Now we're looking for 2 numbers, 2 factors that add to 8 and multiply to 15. So hopefully you are saying that that's going to be 3 and 5. Order doesn't matter. 3 and 5, 5 and 3, that's the same thing. So now 3 divided by 1 is positive 3, so my factor is x plus 3. And 5 divided by 1 is 5, so that's going to be x plus 5. All right, on to number 2. Same process. It's in standard form. They do not have a greatest common factor. It's not one of those difference of squares or a perfect square trinomial, because if it was a perfect square trinomial, this would be perfect, and so would this, but it's not. So let's go to the X method. Let's go A is 1, B is negative 12, and C is 20. So let's do the X method here. B at the top, divide by A, multiply A times C. So we need 2 numbers that add to negative 12, but multiply to 20. In this case, I'm going to say it's negative 10 and negative 2. Negative 10 minus 2 is negative 12. Negative 10 times negative 2 is 20. Negative 10 divided by 1 is negative 10, so x minus 10. Negative 2 divided by 1 is x minus 2. All right, on to the next one. Okay, so this one right here, standard form, no greatest common factor. Now this one, we're going to talk about those perfect square trinomials. It's not a difference of 2 squares, but it is a perfect square trinomial. So let's kind of talk about how we can see these and how we can actually work these out. So first off, I'm going to take this one and work it up here as a, actually, let's do the X method first. So let's say we didn't see the perfect square trinomial, so we would still identify A is 1, B is 6, and C is 9. So when I do the X method, we have B on the top, we divide by A, which is 1, and then we do A times C, which is 9. So our 2 numbers that add to 6 and multiply to 9 are both going to be 3's. So 3 divided by 1 is positive 3, and 3 divided by 1 is positive 3. And since they're both the same, we're going to write x plus 3 squared. Okay, so let's talk about how to do the shortcut on this. So the first thing I want you to notice is when we get to the, is it a special factor? Is it a special case? Well, first off, x squared is a perfect square, right? That's x times x. 9 is also a perfect square, which is 3 times 3. So right here, let's see, put this right here, x squared plus 6x plus 9. So what we're going to do is we're going to take the square root of this first term, which is going to be x. we're gonna take the square root of the third term, which is 3. Now, to check if it is actually a special case or not, we're gonna take these two numbers, x and 3, we're gonna multiply them. So x times 3 is 3x. Then we're gonna take 3x and we're gonna double that. And 2 times 3x is actually 6x. Since it is the middle term, we use the middle symbol and then we square it. And that's how we get x plus 3 squared. So you notice both these answers are the same. So again, take the square root, x, square root of the third term, 3, multiply together, x times 3 is 3x, double it, you get the middle term, then it's a perfect square trinomial. Use the middle sign, so x plus 3 squared. All right, number 4. First step, is it in standard form? Yes, ax squared plus bx plus c. Second step, do we have a greatest common factor? Well, I'm looking at these, and they're all divisible by 2. So we have x squared minus 6x plus 8. This is not one of those special cases. This is a perfect square, but that's not, and I have no difference of squares. So I'm gonna go to the x method. So we can see that a is now 1, b is now negative 6, and c is equal to 8. So for the x method, we have negative 6 on the top. We divide by a, which is 1, and then a times c is gonna be positive 8. So my factors are gonna be that add to negative 6, but multiplied to 8 would be negative 2 minus 4. So negative 2 minus 4 is negative 6. Negative 2 times negative 4 is 8. So now, when we draw our factors, be careful not to forget this 2 right here, because that's going to be in the front. That's my first factor. Negative 2 divided by 1 is x minus 2. Negative 4 divided by 1 is going to be x minus 4. All right. So let's keep going and factoring a little bit more, a few more of these. Then we're going to come back to that solving piece. All right, number 5. First question, is it in standard form? Yes. Is there a greatest common factor? Actually, there is. Negative x squared, negative 11x, negative 10, they're all divisible by that negative sign. You can put negative 1, I'm just gonna put a negative sign. So divide each one by negative, you get x squared plus 11x plus 10. All right, it's not a special case, well, let's identify a is 1, b is 11, and c is 10. X method. 11 on the top, divide by a, which is 1. 1 times 10 is 10. So the two numbers that add together to 11 and multiply to 10. Now, usually when they're within 1 of each other, like 11 and 10 are within 1 of each other, one of the factors has got to be 10. And 10 plus 1 is 11, and 10 times 1 is 1. Okay. So once again, when you write your factored form here, your intercept form, don't forget that GCF. 10 divided by 1 is positive 10, so x plus 10. 1 divided by 1 is positive 1. All right, let's take a look at number 6 here. Is it in standard form? Yes. Is there a greatest common factor? Yeah, they are all divisible by negative 3. So we have x squared minus 6x, and that would be positive 9. Is it a special case? I'm looking at this. This is a perfect square, and so is this. So let's see if this works out. We have the square root of x squared is x. The square root of 9 is 3. X times 3 is 3x. Double it, you actually do get 6x. So we use the middle symbol, parentheses squared. Don't forget your GCF. And there it is. You can also do the x method here, but try getting the hang of the shortcut. It will help. All right, next one, x squared minus 16. So first thing I noticed is there are only 2 terms, okay? So is it in standard form? Yes. Is there a greatest common factor between these two? No. Is it a special case? It is, right? Because this is a perfect square, this is a perfect square, and we have a minus sign, right? So this is ax squared, and just to see, there's no bx. So if we took the square root of x, we would get x. If we took the square root of 16, we would get 4. We know to write it twice. First one I always make positive, the second one is negative. Now, I'm gonna show you the x method in case that's something you wanna try on this. On this one, it is doable, but just kind of watch. So a is 1, b is 0, c is negative 16. So in this case, b is 0 on the top, divide by a, which is 1, and then 1 times negative 16 is negative 16, so that's going to be 4 minus 4. 4 minus 4 is 0. 4 times negative 4 is negative 16, so 4 divided by 1 is x plus 4. Negative 4 divided by 1 is x minus 4. So it is doable through the x method, but just try to get a hang of these shortcuts. They do speed up the process. So again, I hope you can see on number 8, Yes, it's in standard form. There is no greatest common factor. And again, we see a difference of two squares, right? So it's one of those special cases. Square root of this is x. The square root of 36 is 6. Write it twice. The first one I like to make positive. The second one is negative. You can also do the x method to verify that. All right, so now we're getting to solving, all right? So with solving, we have to do just one additional step. And let's take a look at what that additional step is. All right, so let me go back to the previous notes and fill that part in for you. Here it is right here. So steps to solving. Set each factor equal to 0 and solve for x. So pretty much, if you look at these previous problems that we have, you're really just doing the x method and you're setting it equal to 0 and you're solving it. So it's kind of what we've already done from last week on Thursday. But let's go ahead and put this all together. So step 1, is it in standard form? Yes. Is there a greatest common factor? No. Is it a special case? Well, there's 3 terms, so perfect square, not a perfect square, so it's not a special case. And now we're gonna look to do the x method. So a is 1, b is 2, and c is negative 3. X method, b is on the top, divide by a, which is 1. 1 times negative 3 is negative 3. So my factors that add to 2 and multiply to negative 3 are going to be 3 and 1. So 3 minus 1 is 2, and 3 times negative 1 is negative 3. So we have x, 3 divided by 1 is positive 3. Negative 1 divided by 1 is negative 1, so x minus 1. Okay, so now we have x plus 3 and x minus 1. So we're going to set each one equal to 0. So subtract the 3. X equals to negative 3. Add the 1. X equals to 1. So those are my 2 solutions. Okay. So that extra step is just taking your factored form, set of each equal to 0, and solve. Now, number 10, be careful. Number 10 is a different one, right? Notice there is no C value. But first question, is it in standard form? Yes. Is there a greatest common factor? Well, considering there's only 2 terms and it's x squared and bx, they should have a common factor. They're both divisible by x. And then x times x is x squared, and x times positive 4 is 4x. Now, usually when you have the GCF and it's just these 2 terms, whenever you factor out the GCF, that's pretty much factored right there. So this is what we did on Thursday. Okay, so now I can see that it's completely factored. So now I'm gonna set each of my factors equal to 0. So this one is actually done. On this one I subtract 4, and x equals negative 4. All right, let's take a look at number 11. Again, it is in standard form. There is no greatest common factor. Is it a special case? Well, perfect square, not a perfect square. So we go to the x method. A is equal to 1, b is equal to negative 1, and c is equal to negative 20. All right, from here, x method, negative 1 on the top, divide by 1. 1 times negative 20 is negative 20. My factors that add to negative 1 but multiply negative 20 are going to be 5 and 4 and negative 5, right? Negative 5 plus 4 is negative 1. Negative 5 times 4 is negative 20. So this would be x minus 5. This would be x plus 4. Set equal to 0. Now we set each factor equal to 0, and we solve. At this point here, I'm just going to solve x equals 5 and x equals to negative 4. All right, down to the last 3. Number 12. Again, standard form, yes. Greatest common factor, there actually is one. There's only 2 terms, and they both have an x, so we factor out the x. X times x is x squared. X times negative 2 is negative 2x. Set each factor equal to 0. First one is solved. The second one, we add 2 to the other side, and x equals 2. All right, 13. GCF, or sorry, is it in standard form? Yes. Is there a GCF? Yes. I like to keep my x squared term positive, so I'm going to factor out that negative sign. So x squared plus 9x minus 10 equals 0. It is not a special case, so we go to the x method. A is 1, b is 9, C is negative 10. So 9 on the top, divide by A, which is 1. 1 times negative 10 is negative 10. They're right next to each other, so 1 is 10 and 1 is 1. So 10 minus 1 is 9. 10 times negative 1 is negative 10. All right, so it's going to be x plus 10 when we divide by 1 and x minus 1. Set each factor equal to 0. Subtract the 10, x equals to negative 10. Add the 1, x equals to positive 1. All right, and down to this last one right here. X squared minus 4 equals 0. Standard form? Yes. Greatest common factor between the two? No. Is it a special case? Yes. We have a perfect square, and there's a minus. So square root of x squared is x. Square root of 4 is 2. First one's positive, second one's negative. All right, set our factors equal to 0. Subtract the 2, x equals to negative 2. Add the 2, x equals to positive 2. All right, and that concludes the notes.